Good morning again, back to you. 28 June 2020, there was a disturbance. I want to give some information specific, particular information in competency of engineers. Competency is very important from field point of view. That competency, which you have to understand very well. Competency of engineers, civil engineers. Now, what is competency? First of all, you have to understand that. What does competency mean? Such terms we don't understand law-wise. We have to understand those terms. First of all, legal competency, then personal competency, and then work competency. And on top of that, complete quality system you must have yourself. Quality system that operates on projects on company organization, that's different. I'm not talking about. I'm talking of your own quality system. You may have a degree in engineering, post-graduation, or be doctorate, whatever you have, that's different. And that's nothing to do with quality system. That is your educational system, academics. I'm not talking of that. I'm talking of something else. That is exclusively different, and that is total quality. That is total quality, and project management total quality. It's not that easy as you have understood so far. I'm talking about various issues on engineering, management, construction. Those are based on my experience, not from books. I'm not referring to any book because I want to express my opinions based on my performance. That I could succeed or not succeed doesn't matter, but I performed field, making many mistakes in my life. I learn from them. Everybody makes mistakes who does, and who says I don't make mistake, that person falsifies. Mistake is root of learning, means mistake means take is included in that. So you are taking means you are mistaking as well. It doesn't matter. It happens as far as that mistake is correctable. You can apply correction on that. You are working alone. No. Question is that you are not alone. We have to work in a building. Let's take example of building. In a building we work from base to top. Forget finishes. Forget. Think of structure. Finishes depend on structure. Structure does not depend on finishes. You have to understand this basic point. This means your structural knowledge gives something concrete, gives something reliable. Reliable means safety, or safe plus service giving plus long-term traveler or durability. Your material, your product should give reliability, and if you can't do that, you don't claim your engineer. Your product is not discipline. Your product is engineering. You cannot say I am in designs, I don't know about that. I am in planning, I don't know about that. I am on site, I don't know this. If you say that, you are half, or 40, 30%. Do you want that status? Means you are not complete engineer. Yes, you are perfect in one or expert in one, you are half in one, that is acceptable. But you are able to coordinate, you are able to relate all these disciplines, that's most important. If you understand that point, it's okay. Engineering does not come all from books. Engineering does not come all from books. Engineering does come by common sense. Engineering does come by vision. Engineering does come by mind operation. Engineering comes because of determination. Engineering comes if you believe in change. Engineering comes if you believe in risk. And if you don't believe that, you can't do engineering. Engineering is not predefined, you have to define it. Yes, codes are defined, specification may be defined, but you have to evolve procedures yourself. No procedure is defined. Procedures you have to evolve. Technologies are defined, but you can give technology, no problem. You do on that. Who stops you? But root of a tree is more important than tree. When you study in university, you are given a right to think. and that right is yours. No one can take that right from you. And if you can't think, you just go behind people to get some information, then you can't be called an engineer. Yes, you go. Nobody says don't go. But when you fail in your attempts, you go. Otherwise, you are not an engineer. Really. I always say engineer means a person who is genius. Because you are going to create something which is unknown. Even if you use architect drawings, architect produced drawings, you have to generate something which even architect does not know. So there is a difference. I'm not talking of conflict, no, don't take that way. I am just talking of reality, that you can change yourself first, your school of thoughts, your mindset, and don't go behind everything that others say. Don't go too much behind that. When you design something, let us say building, why should I think about column directly or beam directly? I have to think of that building in its perspective, in its isometric form. I have to see, even I have a drawing given by someone else, I have to rethink on that. That's my basic job. That is engineering. If you cannot have that formation, mechanism, philosophy within yourself, then what sort of engineer you are? Just a designer or just a prosecutor on site? No. You must have a visionary approach. Yes, softwares are there, yet you have another software in your mind. Have a clear vision what you want to do, then design, not before that. And clear vision of structure I am talking, not of foundations. Foundations in another world, unknown world. You may see something at 1 meter, another at 1.5 meters, another at 6 meters, another at 10 meters, depending on soil stratification. You cannot generalize it, but people assume that is best and most reliable material where you have to rest your foundation. That material is called soil. It's not rag, it's material. It's going to support you, your foundation, your building, from all directions. Do you know what is that? Soil is never uniform in stratification or in its 3 dimensions. It never is constant. It keeps on moving invisibly. It has many structures within itself, and it contains water also. It contains various, you can say, compositions like clay, silt, lime, many others. Rocks also of different nature. So until you know thoroughly about that world, but you design, you say I am designing based on assumption, okay, but you may design a small building for that. But if you want to work on a big project, like a facility project, ethylene plant, alkali plant, or refinery, or something else, or power station, or a big industry, you can't assume. They may say, you assume, no, I can't assume, finish. I want soil investigation. If you want this project, you have to conduct soil investigation. And I have to, total area I want to investigate. I want to investigate total area, wherever your structure has to come, and surrounding areas also, because envelope makes a difference. And depends on, I want 20 meters deep boreholes, or around 30 meters deep, or I want 10 meters deep, that depends upon your choice. What sort of structure is that? If you think maybe you need pile in there, maybe you need not. Maybe you need only massive block of concrete, or you may need raft beams. That depends. You can't decide immediately based on employer's statement. No, I can't. I want investigation, and investigation through professional laboratory, not by any layman laboratory. You know what is soil investigation. You know all technique of that. You know what factors you require answers from site. It may be clay soil, it may be silt soil, it may be sandy soil, it may be a mix of this, it may be rock, it may be water, some water available, it may be content salts. Water mobility, big question mark there. N factor is a question mark there. Cohesion, shear strength. There may be many points there to consider. Rock quality designation may be a big point. Rock quality, rock recovery may be a big point. There are so many parameters you have to decide. Maybe you don't know, you are unknown to that. So what to do? It's complete profession. Profession in a sense, it takes time. If you want bore log reports, I want 20 meters per bore log reports, or 30 meters, or 10 meters, whatever you have decided, depending on the requirement. And I want so many boreholes at these locations I want. My structures are coming heavily here, I want this. Maybe you need 50 boreholes, maybe you need 25 boreholes, maybe you need 100 boreholes. You have to conduct soil investigation in those areas. It takes time. Reporting takes time, but you need it. You need load bearing test. You need bore report. You need some other report, laboratory test, samples, soil samples. You have a lot of requirement there. I have a file, 2 or 3 files for soil investigation, but those are copyright-oriented file. I can't publish them. I shall try to put them somewhere in some website sometime, because they are big files. They're not easy to put in. And if you put in there or post them, it's difficult to download because they charge money. Script.com, for example, I have put many files there of my work. And because there is no other site where I can put it there. Excel file, Words file, PDF file. So we have to check this. Soil report is never in 2 or 3 pages. It's complete doc. You have to say history of area. What was history? How it worked in 50 years, 100 years, 200 years. There must be some. Where is the reclaimed soil or original soil? Maybe somebody reclaimed that. Who knows? It generally happens. This new airport of Qatar was built on the reclaimed area. The sea was filled in. It was based on the reclaimed area. There are so many such sites where this happened. That must be pulled in. Otherwise, you cannot say, I have done my best. And that report you have to understand, because it's very much technical. There is nothing that you can say administrative. It's completely technical. History is technical. All types of ages are shown in that. If really it is a report, what was status of rain, what was status of seismic actions, that must be reflected in that. And then you must have conducted many at many levels load bearing tests, where you think building is only 1 story or 2 story, and when there is a tower in that, also high building, flare tower is there, or central building, so you can say central control building is there, or process plant is there, you will require different types of foundations there. So you must have a reporting like that. So you may be having many bore logs, many C values, many N values, many RQDs values, and you will have many more parameters reported from that through that soil. And if you are not getting that, then you are deceiving yourself. Don't deceive yourself. Don't depend on the professor of university or IIT that will give you a report. No, that's not professional report. We don't want theoretical report, we want professional report. I have seen reported by so many professors and also field people. Both are different. No report can become 2-3 pages report. It should be a descriptive report to understand what is there. You see recommendation of what recommendations are given by specialists who generally, doctors, not doctors of engineering, but doctors of sciences, the rock mechanics, I'm not saying that they are expert in everything, but understanding of report or comprehending that report is also a very important factor. But we can't do that. Don't shy. Demand if you can, if you're really an engineer. And generally, we have seen means not only foundations but also collapse or tilting of buildings. Not here in China, you have seen, in Italy or many other countries have seen that. How it's happening? Because of lack of concentration of work at time of design, at time of soil investigation, or maybe there was no soil investigation, at a time of executing. Same execution or prosecution of works is more important than design, because people are ignorant or they have milestones they want to deliver, which is not practically possible to be delivered because there's no optimized time for duration of complete, or they start late in the recorded time and they make mistakes. And don't think consultants are very smart every year. No, they are not. Or don't think engineers some sites are so. No, they are not. And quality people don't care for that. They don't care for designs, though it's their responsibility also. Quality means what? Only working quality or every quality? Well, I'm not here to criticize someone. My purpose is professional. If we cannot do that, we deny ourselves what we learned. Don't depend on just small information. You can check some soil yourself. If it's small project, let's say you're constructing 2-story building, 3-story building, small building. What you do? You want to know what is soil. It's very simple. You can do that. Nobody says don't do that. Now I'll show you something if you can understand that. It's not technical, it's not a very big issue, means just you can say it's a very small part of that. Though you make it a layman job, but it gives information, it gives some reliable information to understand what composition of soils is. That's an important part of that. Maybe I take that photograph, I don't remember, it's just comic. It should be there somewhere. I have not deleted that. You generally don't delete that, but it should be somewhere. Yeah, it's there. Oh, no, not that. Not that. Yeah, it's there, yes. Now, I'll show you something here. Oh, please don't send your messages, digits, yeah, they won't understand. These people can't understand that. You see what I'm showing to you? This is small glass tumbler full of soil. I stirred and dissolved that here, and then I waited for settlement. You see what sort of soil it is. You can see that. There are different layers. Some layer is concentrated well, some is less concentration up to less composition. This one that. No. Just to see composition of soil, how to see that. Just to an idea. I mean, it's what there is a clay or sand or silt. Whether you can rely on that or cannot rely on that. And also like to do another one, same but another one. Maybe another one I have. No, it's not there. Yeah, it's another one. You can see this way. So what I tried to show you was little sample, layman sample. You can see just dissolve something on soil. I waited for 2 hours, 3 hours to see settlement factor, and it shows that there's a lot of clay in that, and there's a lot of silt in that. Maybe sand, some particle of sand also. So how this cohesive mix, or you can say this matrix work You have to understand that. When there's clay is a danger, means it's danger both the swelling as well as shrinking. So you are inviting problems for yourself. But if you explain to someone, they won't understand. No, they don't understand. I told this person, don't excavate, stop excavation. This person did not stop excavation. He already started excavation, then came to me, this is my drawing, architect prepared this, the this drawing is right or not. I said, no, this is wrong drawing. I told him clearly, your architect prepared wrong drawing, I don't trust, I can't work on this drawing. Because this is very old drawing, a different type of, no, I can't. If you want to work, immediately stop excavation. I want to see soil and I want to see what is best for your foundation. But who bothers, You think people bother? He is thinking of money spending on excavator, is not thinking of future of building. But he wanted certain engineer support. Of what was purpose going to architect them. Architect copied and pasted and gave it to him. No meaning, no need of information of soil. Soil you can place building on the soil, it's having clay and silt mix. And if you can play, but you have different design for that. You cannot say I'll put an isolated footing on this and put 3-story building on that. That too industrial, which having major spans on that. But these people do. What to do? I ask him, I call this contractor, can you do this? He say we'll discuss and come back, and never came back. Never. And they might have completed that building. What can I do? My question is, you cannot explain to people. But you can explain to them, if you get a job, by chance, okay, you didn't get a job, that's different, but you got a job then. If you got a job, it's your duty to do it right. You cannot deceive yourself. Yes, your contractor may not agree, your client may not agree. Do you agree? They must say, okay, they would advise you to take so much capacity. Means who are they to advise you? Either you do what I said, you understand it's correct, you go to site and see how can you see, you have to excavate, you take something, or you call some laboratory and test bearing capacity, or bring truck and do plate bearing test and do that. Nobody would call. So what's function of engineering there then? So this means engineering is fake. I would simply say engineering design and engineering execution both are fake. Nothing to do with practical profession. Is it wrong? Say. Is it right to say? What is right or wrong? You are not following anything. You are not following texts of books. You are not following conventions. You are not following anything. But they want to work. And it happened many times with me. They just want within, then give me now, as if this is your pan masala, or this is your chai patti, or this is your milk, or your juice, or take it now and go and use it. Very, if you deal with people who do not know anything, you face like this. I have faced, that's why I could not stay here. People do like that. They don't respect anything. They would decide themselves before then come to you. We are doing this right or wrong. Well, this happens in profession. What to do? Every type of people are available in this world, and you cannot differentiate. If you get good people, that's nice. Means if you get educated people, good client, you can convince them. This is necessary. This is an important case every time. So I was telling about soil investigation. Soil investigation requires your knowledge of soil, not degree. It requires your knowledge of soil. You might have studied only a few parameters of soil in the construction engineering when you were in engineering, but it's not that. You have to go through many soil reports if you want to learn soil engineering. It's not your books. No books will give you. The books written by professors, and they are not practically oriented. Unfortunately, they write books. We don't want formula there. No need of formula. We want practical aspect. What report says, what bore loads speak, what plate loads speak, what your N factor speaks, and what you are, yes, depth of found, there are formula to find so anything, but formula is not that important as a report from site. Soil mobility is very important. Soil mobility is unknown. It can't be predicted, but soil mobility means water. Soil mobility means water moves and takes soil particles with it, clay particles and take with it, and sulfates can take it dissolved in water, and this means this can strike your foundation. This moves from one place to another place, say it moves 50 meters in 10 years. It can cause defect somewhere and push somewhere else. Continuous movement, you can't stop it. This continuous movement in water mobility is called water Soil water mobility is very big factor where there's water table. Yes, where the snow you go down 30 meters, there's no water, go 20 meters, no water, 10 meters, that's it. But where you're taking a foundation, there's a difference of 0.5 to 1 meter, 2 meters in the level of water. It can rise due to rain, and this comes to contact your water and water mobility, soil water mobility brings salts to that. It can attack your foundation surfaces. That causes a problem. It can go down to your foundation, and or we can say if it's clay, then it can, if you're not applied soil improvement method, it can cause a problem. Soil improvement comes into play there, or you have taken pile foundation down to rock bottom, that's different one. But everything cannot be done by piling. You just construct a 2-story building, shall you pile for that? Maybe you have to be maximum. The raft beam can also rest on the clay. Shall you allow that? If let us say 1 meter clay below your foundation, shall you allow that? Certainly not. You say, no, I want to improve that. You have to remove 30, 40, 50 centimeter and improve that soil. Can you do it? It may cost some extension, but if you don't do that, water goes below, what shall happen? If soil swells, and what shall happen later on when it dries out? This is a point to be considered, very important points, not simply soil investigation or design of building. It's a combination of both. Nobody can predict soil. Yes, if it's rock, fine, there's no much chances as such. If hard rock or medium rock, soft rock, hard rock, medium means if it's 20 ton, 25 ton, 30 ton, 20 tons density, you can simply say, I will assume 15 tons or I will assume 20 tons. In that case, you are safe. But yes, fissures may be there, faults may be there. Something can be there, anything can be there. But that's the 2-3 building, that's not going to cause havoc on that. But while you're going to do structure, heavy structure on that, heavy structure in the sense you're going to found certain compressors, thousands of HP compressors. You're going to found some vibratory compressors, not stationary, vibratory equipment. This causes a problem. It's question marks. That causes a question mark. Heavy machine foundation, heavy equipment foundation. Well, if stationary is acceptable, vibration is very important. There is much vibration, dynamic forces come from there. That causes an issue. So what I'm stating is, don't simply assume, conduct it. Soil investigation is very interesting actually, because to understand that, you need to understand difference between soil, clay soil, silt soil, sand soil, limestone, rock, soft soil, crushed soil. So many soils are here, and you understand what are their properties, what are liquid limits, means plastic limits, Atterberg limits. You have to understand all that. That gives you an input to put that. So otherwise you shall always even confused, mix up, means which is best, particle size of clay, particle size of silt, particle size of angle of repose of sand, means so many parameters count there. Value of C, value of N, value of RQD, recoveries, and means it depends, means what you are doing. And no answer is perfect. Remember, every answer is conditional, qualified answer. No answer is independent. No one can give independent answer because you don't know facts. We assume something by results. Even results are not perfect. They may recommend, your technique, your laboratory manager would recommend you can take this much. Clearly they can't say also because they are not sure. So it's such a complicated but interesting, I would say. If you are an engineer, from engineering point it's very interesting because you know at least what behavior this soil would give in 30 years, 20 years. If there's say some canal nearby or water body nearby, it's a different type of behavior. It's a not dry area and seismic action, and it depends upon location of that. But you will have majority of information available with you. So it makes you, this information makes you easy to decide. It makes easy decision, reliable decision to some extent. I cannot say perfect decision, but working decision. That's what is required. This is my specific talk to you regarding soil, because I have seen many reports of soil. I have gone to study them to some extent, and I felt happy with that. Well, I could not find those reports in my engineering syllabuses, and I could not find those books, those reports. Even by highest written, highest scholars, highest professors written. Those books are practical soil reports, and if you can search those, maybe you won't find on internet, because these are trade secrets, and these are, you can say, secrets of those people. But if you have worked somewhere in big company, you must have been exposed to those reports due to your being engineering in site or in field. You must have done something. If you have that, fine. I had those reports. I was really. It takes time to study, but it's useful. Even if you can't understand everything, you can understand a lot of that. Means how many borehole reports, varying in every depth, and say, and how many curves and how many graphs and how many and values and relations linked to this and that. Means it takes time to say more than your PhD book, because this is a practical book, this is exact book, this is not guided by someone, this is based on real tests. That's very important point. So I was pleased to do that, and I learned a lot. In fact, I learned a lot from there. How can soil behave, conduct in future? That's most important point. You can learn in field, but you can't learn in your university. That's main point. So with this say, I will close this. It's already too late. Thank you very much. This was my special talk because there was a disturbance in the last video. So thanks again, once again. That's okay, fine.